We are answering different questions about time in order to develop a coherent theory of time. And this question we are discussing in this video is, why does time move forwards? So we say that time moves from past to future, and there are also many processes that seem to occur in just one direction. So for instance, we often see glass breaking, but we don't see a lot of pieces of glass popping together and become a vase or glass or something. Or we see an ice cube melting in a glass of Coke, but we don't see a glass of Coke where suddenly a lot of water molecules go together to form an ice cube. But if you look in textbooks in physics, they will usually say that the laws of nature are time symmetric. There's nothing in the laws of nature indicating that processes should happen in one direction instead of another. And this is what causes in the question, why does time move forwards? And it's also called the problem with the arrow of time, or arrows of time. So that's the question we're discussing now. And my suggestion for a solution is to say that people are often mixing different questions into, when they're talking about this, they're mixing these different topics that we need to distinguish from each other. And we'll start by distinguishing between processes occurring in the world and time as a measurement of motion. So you can ask, why is it the case that some processes occur only in one direction? And that's another question from, why does time move in just one direction? So moving from past to future. If we think of time then as a measurement of motion, as I've been arguing, so you can make this timeline divide into days and hours and seconds, etc. Well, then this line is by definition an arrow moving from past to future. So even if all processes in the universe had started going backwards, time as this timeline, as this measurement of motion, would still be moving forwards from past to future. That's what would make it possible to say at all that the processes had started going backwards. And so if someone was sitting outside of our universe, looking at our universe, they say that processes are going backwards and time is still moving forwards. Time as this measurement of motion. So that's one question of the timeline, which goes in one direction because it's defined that way, which is another question of, why do some processes occur only in one direction? And again, often the answer you will read to this is that it's a question of entropy, that over time some processes are very probable to occur. For instance, putting an ice cube in a glass of water, how the particles hit each other, etc., will make it very likely that the ice cube will melt. But it is possible that water molecules could go together and form an ice cube, but it's very, very unlikely compared to the ice cube melting, and that's why you always see the ice cube melting and not water forming an ice cube inside the glass of Coke. But that's not the whole answer. There's a very good philosopher of physics called David Albert, who writes that most physics books are inaccurate here. They describe laws of nature at a very coarse-grained level, just describing particles. But if we look into details in the physics that we have today, we see that there are also laws that make processes have only one direction. So B meson decay would be an example of a process in nature with this kind of elementary particle called the B meson, and that happens in one direction only, and because of the laws and not because of entropy. So why time move forward in the definition of measurement of time? It's by definition. Why do some processes only occur in one direction? Well, some processes occur in different directions. Some processes occur in only one direction, and some of them is because of, it's very statistically likely, but it could go in another direction. And sometimes processes happen in only one direction because of laws of nature, such as, for instance, B meson decay. So to summarize, I've said that in essence, time is reducible to motion. And so time in the sense of motion, that's motion, movement happening in the world in all sorts of directions or circular or whatever. But it's time as a measurement of motion that has a direction because it's so defined. Some processes have a direction, other processes do not. But now we could object, well, what if all processes started going backwards? Then also our measuring of time would go backwards. So if I was reading at the clock and say now it's gone 5 seconds, but if everything started going backwards, then the clock would read 4, 3, so even the measurement of time would go backwards. And that's true. And so we need to distinguish, as I have before also, between time as a measurement, abstractly understood, this time arrow, and actual time measurement when actual individuals measure time. So again, if all processes in our universe started going backwards, we would lose memories, and what we were reading on clocks, etc., would go backwards. But people looking outside of our universe, or if we left our universe, would see then that, oh, their actual measurements of time are now going backwards, but time is still moving forwards. And even if all universes, all processes in all universe and all of reality started going backwards, you would still have this abstract measurement of time moving forwards, making it true that all processes in all of reality were going backwards, and then all actual time measurements would be going backwards. Time would still be going forward. Time as a measurement, abstractly understood. So we need to make these distinctions, and when we do so, we can say exactly what it means that time has a direction, and we can explain why time has a direction. But we just need to be clear about what we're talking about, and then the problem is solved. This way of thinking about time is also another explanation of why the past cannot be changed, because the past, it's just on this abstract arrow, but only the present moment exists, so the past doesn't exist, and what doesn't exist is not something that you can change either. That's what I had to say about the measurement of time in this video.